looks like. Let me give you some notation, okay, for some language and some notation for these kinds of graphs. These kinds of graphs that have x's in denominators. Okay. Okay, so for f of x equals 1 over x, the y-axis and also the x-axis are what are called asymptotes, and I will spell that, asymptotes for the graph. It means that, well, it means something very precise, but roughly, for the y-axis being an asymptote, the closer x gets to 0, okay, the y values get larger and larger, which means that the graph gets closer and closer to the y-axis. And same thing on the other side. The closer x gets to 0, the closer the graph gets to the y-axis. Okay? So the y-axis is a vertical asymptote for the graph. Asymptote for the graph. Okay? So 1. The y-axis, what is the equation of the y-axis? The y-axis is a vertical line, and every vertical line has what kind of equation? What if I have a vertical line where all the x-coordinates equal 5? The equation of that vertical line is x equals 5. If I have a vertical line, the y-axis, where all the x-coordinates equal 0, the equation of the vertical line is x equals 0. That is the equation of the y-axis. So the y-axis is well, it's vertical, but the word is asymptote, A-S-Y-M-P-T-O-T-E, a vertical asymptote for the graph. And similarly, for this graph, the x-axis, what is the equation of the x-axis? Y equals 0. The y-axis is an asymptote, an horizontal asymptote for the graph, which means that the larger the x's are, okay, the smaller the y's are, which means that the graph gets closer and closer to the x-axis. And similarly over here, as x gets really large in this direction, the graph gets closer and closer to the x-axis because the y's are getting closer and closer to 0. I think I'll wait until later to give us the actual notation, but so the x-axis, have equation y equals 0, is a horizontal asymptote for the graph. Now, when you have a vertical asymptote for your graph, okay, this vertical asymptote for the graph occurred at the x value that made the function undefined, that made us divide by 0. That's how vertical asymptotes are always going to occur. They're going to occur at any x value that makes you divide by 0, okay? Now, of course, we knew the domain of the function because, you know, we looked at the function and said, uh-oh, I can't plug in x equals 0. My domain is the set of all x such that x is not equal to 0. Of course, I can get that from the equation. but I want you to also see that you can see that from the graph, okay? So if you're reading along this graph, along the x-axis, okay, all of these x's are in the domain. -1 is in the domain, -1/2 is in the domain, -1/10 is in the domain, -1/100th is in the domain, but 0 is not in the domain. At x equals 0, there is no point on the graph. That's why we have a vertical asymptote at x equals 0. And then after x equals 0, no matter how small the x is, x equals 1/1,000,000th is in the domain. X equals 1 is in the domain. All of these positive x's are in the domain. Okay, but where you have that vertical asymptote at x equals 0, that number 0 is not in the domain. That's how you see it graphically. So, same domain. I mean, I suppose you could write it, -∞ to 0, excluding 0, union 0, excluding 0 to infinity. Now, the range of this function, okay, we could not see from the equation, but we can see it from the graph. So, are these y values in the graph? Like y equals -7, is it in the graph?
Yes.
Yeah, because this keeps getting smaller and smaller and smaller. Y equals -1 in the range?
Yes.
Y equals -1/2 in the range?
Yes.
Y equals -1/100th in the range?
Yes.
Y equals 0 in the range?
No.
No. This particular graph never hits y equals 0. Okay, on this side, the y values get smaller and smaller, -1/2, -1/3, -1/4, -1/5, -1/100th, -1/1,000,000th, but they never get to 0. 1 over x is never equal to 0. And on this side, the y values get smaller and smaller, but again, they never equal 0. Is positive 1/100th in the range? Yes. Is positive 1 in the range? Yes. Is 5 in the range? Yes. Okay, what's my range? Same as the domain, okay? So I can say, this set of all y such that y is not equal to 0, or I could just say, -∞ to 0, excluding 0, union, excluding 0, parenthesis 0, comma, infinity. Okay? All right, let's take a break. Let's see. I'm going to actually bring a couple of those. Let me see.